I'm a principal architect for Spirent, working with cloud and virtualization here. I'm kind of new, so I'm still figuring out everything, but there's a lot of smart people here in the room, and we're kind of the expert of experts here. We have a little agenda. We'll just go over this. Basically, we'll do some introductions, overview of Spirent. Paul's going to do that. We're going to talk about a couple new things we have going on called continuous cloud validation and EVCI, which is efficient virtualized continuous integration. And then we're going to do a couple demos for you on how we interact with OpenStack. So we'll show you that. And Paul, I think you're up.
Okay.
Paul To, I'll let you introduce yourself.
Hi, my name is Paul To. I'm responsible for strategic market development. And right now, that mostly means I'm focusing on cloud and virtualization. I think I've met a few of you last time. And if you remember last time, we talked a little bit about, our strategy, going into this whole NFV thing, and kind of the largest story on how do we take advantage of some of the virtualization trend and go beyond just testing, because testing, normally people associate testing with, you do that stuff at the end of your development cycle, right? And it's some guy, poor guy, in a really, really noisy lab, right? With a lot of blinking LEDs and, that kind of. But what we're trying to say is testing is, we're trying to make testing cool again, right? And what we're seeing with virtualization and cloud is that on one hand, from lab to live deployment, thanks to all this stuff like OpenStack and so on, that line is really, really blurring, right? And also on the other hand, we started talking a little bit about that last time, and we want to drill down much more during the next 2 hours. Is also at the front end, closer to the development cycle, right? This trends, agile, and the whole concept of continuous integration. So what we're seeing also is all the testing stuff that we do traditionally in the lab, right? With all the SDN, NFV stuff. Now, because everything's virtualized, and when we actually start integrating with things like Jenkins and Jarrett's and GitHubs and those things, now we can actually also kind of engage the developer communities, right? The people that are doing OpenStack apps, people that are doing Neutron plugins and so on, that we can be also at the kind of the front end of the development cycle also. So that's why you're hearing these things called, we're just as guilty, right, in terms of inventing all those acronyms, right? CCV, continuous cloud validation, and EVCI. I don't even remember what EVCI stands for. It's efficient virtualization, right? So anyway, that's what we're going to talk about. Now, before we go into that, I think some of you have heard this before, and also I recognize that we don't have a bunch of bloggers here, we have a bunch of engineers here. So we're trying to not bore you too much. We're going to minimize the marketing stuff. And we also kind of want to take a little bit of risk in that, unlike last time where we did mostly PowerPoint, so this time we're going to be very interactive. Eben is going to jump in and interject, and we also have arranged some live demos, right? So we're going to go back and forth to get you kind of a real taste on what some of these tools actually look like and how they work and so on, right? So let's get the marketing stuff out of the way. Spirent, we do testing, right? And our mission is we do testing, validation, and we also have a division that do what we call assurance. Right, and we also just bought a big data company. So we can actually get all kinds of data, for example, from handsets, from mobile networks, and basically help a mobile provider, for example, to assure, service quality or the end user experience, right? So we do all those kind of things. And then if you look at the spectrum of things that we do, we're mostly in the ICT segment. So we do everything from mobile devices to IP networks, Ethernet, we do huge Ethernet fabric testing. I think that's probably how Spirent is all the smart bits and all that big, huge scale Ethernet tests. But we also do all kinds of like routing tests, protocols, BGP, MPLS. We do security. We have the capability to emulate all kinds of different security attacks. We can do security fuzzing, vulnerability testing, and we also have the ability to emulate user traffic, right? And assume different we have a library of thousands of different application profiles. So which comes into really handy, because a lot of times with virtualization and cloud, what we're finding is that people are less interested in like how many packet per second you can push, but more interested in things like how many HTTP sessions can you support, how many exchange servers. So we actually have to bring in a lot of the different mix of realistic application traffic, right? We do data center stuff, and we even do GPS. Right, so we are also like in the automotive, for example, we're helping people test navigation systems and things like that. And in all these categories, we are either number one or number two in the space. And this is just saying that, hey, we got all kinds of cool customers in the network equipment manufacturer segment, but also service providers, large enterprise and government, as well as wireless and positioning, right? And like I said, I think this is probably what people know Spirent for, is all this kind of quote-unquote expensive God boxes, right? That high number of 10, 40, 100. We just also demonstrated 400 gig testing.
So this is where I can do the show and tell.
There you go.
So this is an example of a 100 gig module we used to have a few years ago. Has 200 gig ports. It's really big and heavy and expensive. And this has 4 times the capacity of that, and it's smaller width-wise and less power. So.
Right. Now, something that is kind of unique in terms of what we do in the industry is that since many years ago, we have moved on to basically all the software, right? All the good stuff that we do in our box, like application, traffic, simulation, security, all the SDN protocols, BGP, routing protocol emulation, all that stuff that we're known for. They are basically software running on x86 cores, right, inside those blades. So, and what that allows us to do is what we call a unified platform architecture, right? It allows us to use the very same software. So from your perspective, it allows us to use the very same test scripts and test methodologies, right, across a whole variety of different footprints, right, from very large to very small. That's actually, I think last time we showed it, is actually a computer on an SD card. It's called the Intel Edison. So a lot of our software actually have the capability to run on something like that, right? And then of course, if we take the software that we're running there and we take it out, right? And because we're already running as VMs, by the way, right, on the x86 inside those blades. So essentially all our software capability, we can take those VMs out and drop it on top of like KVM and ESXi's and so on. And basically now we can run tests, right, between any endpoints. So we could have a VM sitting behind a ESX server, emulating an Exchange server or HTTP server, right? And then we can have like one of this port, it could be a 40 gig port, emulating millions of connections, right? So typically we would use one of those to emulate what we call a cloud of hosts or users, right? Blasting traffic into a simulate or into a data center, right, with VMs, right, emulating as servers. So that's a kind of the basis of a lot of our solutions going into this cloud and virtualization space. So what we mean by continuous cloud validation. So I think this is probably very old news, right, to all of you guys. Like even, as I told you, I learned a lot of this stuff from you a year and a half ago, right? Is the way I kind of summarize the whole SDN and NFV trend is on one hand, everything is getting virtualized, right? On the other hand, all this, separating control plane, data plane is all about programmability, right? So when everything is virtualized and you can instantiate them elastically and everything is programmable, then it's basically all for the purpose of agility, right? And I think over the last 9 months or so, when we started talking to a lot of our service provider type customers that are looking to deploy things like NFV, and looking at things like firewalls and load balancers. How do we scale, right? There are actually some vendors that we work with that actually use OpenStack to dynamically scale firewall functions and so on.
I was going to interrupt and ask any of you guys looking at OpenStack today? Yeah, everybody or nobody? Kind of, maybe. You doing any automation in your data centers? Okay.
What are you using for automation?
Anything I can.
Like
Anything I can. Anything the customer uses.
Okay.
For provisioning machines like Salt, Chef, Puppet, that kind of DevOps tools?
So I've used a few of those. Me and Jason actually have done some work with Ansible specifically.
Ansible, right.
Okay.
Yeah. So.
Okay.
So
how are you orchestrating that? Like, do you have any kind of cloud management to spin up VMs? So the VMs are still...
Sometimes.
Okay.
Sometimes. It's never OpenStack.
All right. So anybody else? Just everybody's manual, like your customers that you're working with, they're kind of not doing clouds? No? Okay. Interesting.
It's all hype.
Huh?
It's all hype.
There's no question there's a lot of people doing OpenStack where just, this crowd in front of you maybe isn't so much.
Okay.
Okay. So in terms of like the SDN and NFV type technologies, what are the kind of technologies that you're mostly dealing with, right? And you're mostly concerned about, or your customers are mostly concerned about? Is it OpenFlow, Open Daylight, NFV?
Cisco Nexus 1000V.
Right.
I think we're all interested in all
Contrail.
of these. I don't know that a lot of us have deployed any of that, but we're definitely interested in that type of thinking and automation.
Okay.
And where
The
it's going.
bottom line is there's still disconnect out there in terms of what we write about a lot of times with emerging technology versus what's really being deployed.
Right.
Sure.
So a lot of people playing with this, but
Yeah,
Right.
exactly.
I think it's driven in part by problem solving too. If you're a telco, you're really into NFV because it's solving certain problems, giving you more flexibility in design and so on.
Right.
Which isn't what most of the people in this room at the moment are. We're not telcos.
Okay.
Typically, we're more enterprise focused, data
nodes.
center focused.
Okay.
Yeah.
Makes sense.
So.
Right. Okay. Thank you. Now, when you are working in an enterprise environment, how much cloud adoptions are you seeing? Like in terms of like hybrid and using things like Amazon, Google's, and Rackspace of the world.
Choose. They're not necessarily saying one or the other, or this model or that model. Excuse me. It's more about what's appropriate for whatever it is that we're trying to do.
Okay.
So they'll say, well, I want email. I'll get that as email as a service thing. If
Office
other thing, I'll do a
365.
platform as a service. I'll do whatever they need to do.
Okay.
But they're not. It's not about saying we will do everything will go in AWS or everything will go in one thing. It's
back to solving the problems with the tools, right?
Right.
Every customer is different.
Yeah,
Absolutely.
So that is great because I kind of went into my marketing mode and even interjected. And actually, what we talk about what we want out of this session is we actually want this because we talk about all this stuff, right? Cloud and this, it's kind of the Wild West, right? And we think that we're kind of learning along the way. And we do a lot of service providers and obviously with equipment manufacturers. And we kind of have a slanted view, right, of the stuff. And then you guys are like right in the front line, right, with the enterprises. So we kind of really, really interesting to kind of look at this as kind of an open conversation about some of the stuff, these challenges, how real are they, and in terms of timeline, what are the most pressing challenges that we can help the industry solve. Because our mission is about validating stuff and providing proof points so that to help speed adoption for a lot of this stuff, right? So we'd love to make this a open conversation, right, throughout, right? So basically what we're saying, so I'm going to cut through this marketing stuff. So there's a lot of FUD starting to increase, right? So it's kind of actually funny, almost a little bit of backslash, right, on virtualization, right? Like IBM SoftLayer is starting to say, hey, rather than, provisioning on hypervisors, it's kind of the same elastic compute model, right? But they provision your apps on dedicated bare metal servers, right? And we actually work with another vendor there. So there's a lot of, and a lot of that it was really, about the predictability, right, in terms of performance, right? So there's a lot of questions on, and us as a testing vendor, we get called in a lot of times to answer that kind of questions, right? What is, like, what kind of SLA can I expect, from all this stuff before I move my mission critical apps, onto the cloud and to all this SDN and NFV stuff, right? Is that what you're seeing with the enterprises? Is that kind of the primary concern, or one of the primary concern, or is this?
I think more recently, as the NFV trend begins to hype up, a lot of customers are now asking, well, is this going to be any less reliable, any more reliable? If we then start sprawling more of these things around, how does it affect like a tiered app when there's so many different bits of NFV doing different things?
Right.
That's a question that I'm certainly seeing more.
Yeah.
Or hearing more.
Anyone else?
Management, right? I fully believe in decoupling, taking a monolithic firewall load balancer and decoupling it and making it n number of virtual appliances. But again, another drawback is if it's not part of a solution, then you're just managing n nodes and it's unmanageable. So then customers will stick with what they know and just stick with that one large appliance.
Right.
Or many large appliances.
Right.
Yeah.
Right.
It's a large failure domain, right? So there's pros and cons.
That's a good point. So it's pretty much along the line of what we're hearing from our customers. Again, the service providers and the equipment manufacturers. And the other angle is, what we're starting to see, because we actually, when we say we have a lot of equipment vendors as customers, is across the spectrum, right? We're dealing with people that are doing underlay stuff, right? In the beginning, it was like open flow based SDN or other underlay kind of technologies, right? And then we have those also customers that are mostly focusing on overlays, right? And now we have those NFV vendors. And the NFV vendors in the beginning were like mostly appliances guys, just doing VMs. But now we're seeing like people like VMware, right, that are introducing all new security model, basically distributed functions right into the fabric. So we're dealing with all those guys also. And when we deal with the end users, and mostly the service providers who are testing this stuff right now, is what we're seeing is that then there's a lot of interest in terms of using things like OpenStack, right, to then actually stitch all this stuff together, right? And going back into that agility thing, there's a lot of idealism that, people are looking at, how do I actually kind of orchestrate all this stuff? And a lot of times the complexity is that, it's not just overlay, underlay, and virtualization at the network level. We're seeing, because we're also seeing the same thing happening on storage, right, and compute. So a lot of times when we go in and say, hey, how do we help a service provider, offer any kind of SLA, right, to the enterprise customers that are buying a cloud service? What we're looking at is like basically this whole stack, right? And when we try to determine the metrics of performance and SLA, we're finding ourselves trying to figure out how we're going to test all this stuff. Now, the good news is, we actually have capabilities to do a lot of that stuff, right? I told you everything that we do on our hardware, we can do as VMs, so that's good. And then we also have a lot of like all the basic, from DCB to VLAN, VXLAN, to OpenFlow. We can emulate OpenFlow switches, large network of, OpenFlow switches to test the controller, and we can emulate the controller to test the networks, like for example, right? And then also we have the ability to do security and emulate application traffic and all that stuff, right? And we can do it across the board.
So I'm going to interrupt you one more time. Can you go back to the slide before this? So my previous question was about cloud and automation. What about virtualization? Is everybody using virtualization? Is that safe to assume? Okay.
Fair.
Are you guys starting to virtualize your firewalls and maybe routers or other kind of network components?
Slowly.
Been doing that for years.
So I noticed Paul and I have been scrambling on this, but you guys were just at Brocade. They have a Viata router that should be on here. So have anyone tried the Viata router out? You can get a free demo of that software, download it, virtual machine. That's a good example. Is the virtual version going to be as fast as my physical replacement that I'm replacing? So those are the kind of things. Are you guys testing those today? How do you test that? Would be one of my questions. If you are testing it, or you just kind of get it out there. Anybody?
I think it's a huge market. Coming from a VAR recently, there's so much, I would say, FUD and just not knowing the performance of virtual appliances.
Yeah.
That you look at the data sheet and you look at maybe a small, medium, large appliance, what the vendor says it can do. But I know at least from where where I was, there was a lack of testing that, because again, as a paid for service, it's out of budget for customers.
Sure.
Right?
And as you said, there's FUD out there. There's a lot of conflicting information.
Yeah.
The guys that are all big on hardware will tell you why x86 can't scale network devices virtually. That's
We all
a bad
remember
place to
back
put 'em and so on.
when VMware came out, it's like, don't put my new application server on a VM. The performance is going to be terrible, right? And now it's like many companies have a virtualization first policy. So I'm sure you guys are
I think
seeing
most people understand that x86 has been proven to be able to do incredible amounts of throughput.
with virtualization.
Yeah.
Right.
Yeah, for sure.
So that FUD is gone
So-
now, but I was working at VMware 2005, 2006, and I was like flabbergasted at how many people didn't want to virtualize.
Well, not every virtual network appliance performs the same, though. So as Jason
There's
was
still
saying.
FUD out there, right? So
Sure.
if you were to see VMware selling, there wouldn't be FUD, right? But if you were to see a vendor who sell lots of hardware,
Yeah.
they also sell software,
Yeah.
you're going to see their sales teams be slighted towards the hardware, no matter
Right.
what. Right now, anyway.
Yeah.
In my personal opinion.
And so would you agree that virtualization is now sort of a trusted thing to have in your enterprise and people feel confident?
Yeah, it's an assumed. It's just
Yeah.
a question of how
For
much.
compute,
Yeah.
for compute, absolutely.
Now what's interesting,
yeah.
But the network, I wouldn't say the network is at a point.
well, here's
where
the thing, right? So we put our virtual machines in the hypervisor, and now we trust that they're working fine. But by doing so, we're actually using a virtual switch, right? And we've now come to accept that as okay. But now these new SDN companies are coming out with their own new virtual switches. Like you guys are going to Nuage after this, and you're going to hear them talk about their SDN solution and how you don't have to use VMware and the VMware virtual switch. Cisco has had the Nexus 1000V for many years. So this is what this is the new frontier for us. So that's really where we're at, and the questions that we're asking are around that.
I guess the stuff there is around the, like I know that I can virtualize a router and I can get X gigabits of throughput with it, and I know that that will work, but it's more about the unpredictability, I guess, or the, I'm comfortable with it, but people are concerned, well, what happens when that hypervisor is under stress because something else is going on or
Thank you.
whatever? People will still talk a bit about oversubscription or whatever. That's this hardware's that cheap now. It's not really such a big deal, but it's still
and even for these guys, right? If we can test that appliance on various types of hardware, different server platforms, different memory, different CPUs, then obviously that would be great.
Right.
All right.
So that's great, and actually you can tell us whether we are on the right path, right? Because just along the line of the very things that you guys just mentioned, in terms of, in addition to kind of all the technology layers, overlay and delay and storage compute and all that, the other challenge that we're seeing is kind of like what you said, right? Is there are a lot of FUD, but then there are a lot of, like in reality, things can, there are examples of like virtual switch and firewalls getting really, really good throughput, right, of x86, on top of hypervisors, right? So in a sense, a lot of this predictability, as a testing company, we get really excited because it's translate opportunity for us, right? And one of the things that we are actually trying to deal with is, in addition to all the technology layers that we talk about, right, there are also like all these variables on the compute environment, right? So a firewall that used to ship on an x86 appliance, right, where the vendor has complete control of the hardware, what driver, what BIOS is running, is one thing, right? But now the enterprise user deploying that VM, half the time you don't even know what kind of server the VM is going on, right? When you have it run on a rack space or whatever, right? So that's that layer of unpredictability that we're seeing, like what is the hardware, what kind of CPU. We've saw things like BIOS settings having really good impact on performance. Now we're also seeing things like, what kind of NIC, right? Do you have the VM assigned to a NIC, right? Or are they sharing, and what kind of, how noisy are your neighbors, right? Are they sharing a NIC? Are they sharing the host? Memory, CPU, core, allocation for the VM. So all those things are kind of like variables, right? That an IT guy would normally have to deal with when they create a VM. They have to kind of make all these decisions. But now we have a lot of people, because even with us shipping our own test VMs, we constantly have to answer those kind of questions, like, what kind of throughput can I get out of a ES6 server? And then we have to go.
It depends.
It depends, right?
Well, I think in the vacuum of data about that, right? Because we don't have any way to quantify any of that.
Right.
Any cases I see where companies are actually looking at virtualizing networking functions, it's usually when performance doesn't matter, right? It's when there's expected to be a low volume, VPN or firewall application, something where you're not concerned about being able to drive throughput.
Right. Who cares, right?
Right. Yeah. You're just trying to get the functionality in a specific spot, but you're not worried about the performance per se. But it's because we don't know what we can do. We don't have any trust in what we think we can do with with
because one of the real problems is if you put a virtual firewall into a situation like that where you're also running maybe the application server and the database server and everything else in that same virtual environment, and now you put it under, let's say there's an attack that comes in or something along those lines, something that's causing that firewall to truly start to work hard. Now, if that firewall is competing for CPU resources and memory resources and everything else at the same time that those same systems are also experiencing that same problem, what happens? How does it break? It's not a question of will it break. It's how does it break? Is it a clean break? Is it something that's recoverable? Or is it, okay, everything shuts down, but now whoever it is that's made the attack has complete access to, into the hypervisor or something along those lines, right?
Is that kind of like, being able to understand, what is the scalability formula?
Right.
How are you going to scale? At which point do I need to worry about an additional host or additional VM instance? Scale out, scale up kind of thing, right? Mm-hmm. Right. So it's kind of funny, you mentioned that a lot of the early use cases are more functional stuff. So are people now kind of moving then into more like looking at, what kind of more performance oriented kind of deployment use case? Do you see that? Like how?
Yeah, what kind of testing do you do?
Yeah.
If it's
usually very, like I'm saying, in those cases where I've been involved in any of that, it's always about a functional situation where we need a little trickle of a VPN somewhere, so we'll do that on a virtual device, right? So there's not really, it's only used in places where we don't have much of a performance concern, and so the test is more functional in nature, right?
Right.
Does the VPN come up? Does the the whatever happen, right? Some simple NAT or something like that.
The other way is the sledgehammer approach of, well, just give it 8 CPU cores and 64 gigs of RAM or something, and it'll be fine. Okay.
The other, okay.
So there's always those free tools. I think DITG, I used that probably last year to test something. Multicast, there's like MC Hammer, the old Nortel tool. So there's some free things out there, but actually, is it accurate? The thing that you're using to test it, how accurate is that? Are the figures skewed? Right. What's testing what? Especially when it's a VM testing another VM, and
Right.
Well, I think your slide speaks to that. So testing matrix is cost prohibitive. I think we leave that to the bigger guys to test their stuff, and then we don't really test our small incremental things that we deploy.
So is that because just the fact that it's cost prohibitive that you have to? But let's say if we can bring it down into something that is easy to consume, something that you can do.
Something more modular in nature than having to buy something.
Right,
ginormous.
or maybe something that, like for example, we can host in the cloud, for example, where we can take care of the infrastructure and we give you access to it.
Yeah, for someone like me, go ahead. I'm sorry.
Like, would you then have to use that kind of tools and methodologies that can actually help you do, quantify performance and scale for this stuff?
Yeah, and maybe you don't want to own a big piece of testing gear. Maybe you have one project, right? And that's all you need it for. So, you don't want to put all the resources in.
Right.
Yeah, assuming it's like a cloud-hosted thing, that we're talking more functionality testing, though, as opposed to performance. Obviously, it's depending on where you're bringing in the connectivity, right, for wherever it's hosted, unless it's a portable VM that you host yourself on a validated set of hardware.
That's cool.
So Eben is going to talk about, we have a concept of what we call virtual private test clouds. And, it's one of the service offering that we are bringing to the market. And it's not just pure virtual, right? So it's actually, we have real hardware test ports that are capable of running really, really high scale, like 10, 40, 100 gig, multiple, of those interfaces. And we also have the capability to provision a test environment that you want or that your customer want on bare metal servers. So basically through a web interface, you can go in, you can VPN in, and you can kind of set up, hey, this is the kind of the application server, or this is the firewall or virtual switch I want to test, right? And then the idea is we're trying to, because part of this problem is, you have to buy a lot of like servers, right? And some of these servers, like some of the, we're doing a virtual switch test right now, and the number of cores and the number of memory they require is like easily $30,000-$40,000 per server, right? Just to do one instance of virtual switch testing. And then on top of that, you have to worry about, you have to become a KVM expert, right? You have to become a VMware expert and all that stuff. So what we're trying to do is in this, what we call the virtual private test cloud, you can by and large use a web interface. Just tell us, I want to test this thing on a ESX 5.1, 5.5, with or without DPDK or KVM, and I want to see the variability of performance, if it's 2 or 4 CPU cores, or 6 or 8 or 24 gig of memory, right? So you can kind of like check those variables, and we actually would automate, all the testing and basically automatically generate a comparison, test report for you, giving you all the benchmark, performance scale and all that
model,
stuff.
are you partnering with the vendors to get access to their equipment?
So there are the open source stuff and the white box stuff we're going to kind of have in our lab, right? And then we also would give you the ability, like if it's a virtual DUT, you can upload that, right? And then we can provision it, into the test environment, right? So for example, and we can provision it on top of the ESX 5.1, run the test, and then we're going to wipe that out and then provision it on a 5.5, run the test, and so on and so forth, right? And automate all that stuff.
Oh, that's cool.
Right?
The only dilemma is hardware, right? Hardware affects that quite a bit. So it's just a matter of trying to match hardware configuration between on-prem and the cloud for testing.
Right.
Where you can get probably a good order of magnitude or a good idea of what it can do.
Right.
But there might be just some hacked up hardware config on-prem, which it just totally blows out at 20% of what you tested.
Right. So that's part of what we're trying to do.
We have ways to address that.
Right.
So we'll get into some of the details.
So you go into that more detail on that.
The question actually on this stuff. So let's just say I have a virtual appliance of Spirent to do testing. Are there other APIs on the appliances to be able to integrate that into testing frameworks?
Oh, absolutely. Yeah, we're going to actually talk about that a little bit.
Okay.
So the concept what I just mentioned is just basically automating. Well, basically, one is take care of the CapEx issue, so you don't have to invest in a lot of like equipment in order to do performance and scale testing, right? And that's on the IT layer. So the other thing that we're also trying to do is kind of extend that concept, right, into kind of this, this overlay, underlay stuff. Like, so for example, wouldn't that be nice that you can automatically quantify the performance of your OpenStack app or deployment and compare that against different Neutron plugins, right? And how does my application work on over VXLAN versus over OpenFlow based SDN? So those are the kind of models we're trying to extend, right? Not just taking care of the variables at the IT layer, but also at the network technology layer, right? So what do you guys think of that? Like, which is more important for you at this point?
Yes. Can we have all of it? Yes, please.
So we have all this stuff under works, and obviously, there's so much to do, right? So it would be really helpful if we get some help in terms of identifying what are the priorities